I wanted to take some time to talk about the game mode and the game state, and just to help you understand a little bit more about why we would use these and how we can use these, how we use them in C++, and how we use them in blueprints. Now, these ideas really come from a design pattern that we call the ModelViewController, and it's one of those software engineering design patterns that we see repeated throughout successful software projects. And usually we think of this a lot of times in terms of graphical user interfaces, but it applies to a lot of different aspects of software. So what is the ModelViewController? Well, it looks something like this. So the model here in your application is the data. So it's the data that your application computes on, that it stores, that it runs on, and all of the operations that happen on the model are built into the controller. So the controller is the logic of your application. And the controller has functions that sort of help define how that model, how you operate on the model. And then finally we have the view, and you often have multiple views, and the views are really exactly sort of what they sound like, which is a view into the data. Okay, so the data of your application. Now you'll notice that there's arrows between these different components, and the reason is because generally the controller communicates directly with the model and vice versa, and the views communicate directly with the controller. And so we don't usually, for example, have the view connect directly to the model, because if you do that, you have a view that's dependent on how the model is organized. And so it ends up being really hard to change your model, and this is why those kind of software products that do that tend to not be very successful, because they're hard to change. And if there's anything you can learn about software, it's that software changes constantly, and especially when it comes to games, that's definitely the case. In terms of a game, what we're going to see is that the game mode is the same thing in essence as the controller. So the idea here is that the game mode is going to act as the overall logic and glue in your game for how your game plays out. The game state is going to be the same thing as the model. So the game state is going to have all the state that is shared, in your game between all the players. Even if you have one player, it's fine. It's still the same concept. And your view are really all of the graphical user interfaces and the cameras that are looking into the game. And if you think about it, the model in your game actually includes a lot more than just the number of coins in the game, but it actually includes a lot of information about the things that are in the game, all of the actors in that, and so forth. And so your view, if it's a camera, is looking into some particular viewpoint in the world. Okay. But when we use the game state, our game state doesn't include specifically those objects, though we can make references to them. But we're really thinking about the things that define your game, the state, that if you were to save the game, this is a good way to think about it actually. If you were to save the game, what information would you need to store in order to be able to recreate it? Well, that's often the stuff that happens in your game state. Now, these things get broken up individually into smaller components. For example, you'll see that there's a player state object that's attached to the player controller and the player's pawn. And the reason is that, some information is better stored at a lower level. And even though your game state might not have that, it might have a reference to your player, and then your player is going to have its own individual state. So we'll see this sort of model view controller, broken down into smaller versions of itself in various levels of your game. Let's look now at creating a game mode and understand how we set this up in Unity. One of the reasons that you want to set it up is that in Unity it uses the game mode to determine which pawn and which controller are going to be used for the players. Now, you might have already put a player in your world outliner, and that's fine, but if you don't put one, and you have a player start object like you'll see here, it sort of defaults to some location in your world, then when your game is executed, it's going to use whatever the default pawn is and create one and locate it at the player start location. And the game mode is going to give it a bunch of settings, a bunch of classes in essence, that are going to define how that behavior works. In order to get to the I should point out that there's, game modes that can be set at different levels. So if I go to the setting and I go to project settings, we can set a game mode for the entire project by coming over here to maps and modes. And this default mode is going to be the default mode that's going to be set up with every map that we have. Okay. And there's a lot of other interesting things here. If you haven't seen it, this will show you which, map is starting when you first load up your Unreal. So the game mode base here, this is the base class of all game modes, and we can change it. If we look here, we can find different game modes that we could add there. And then once you define that, it then lets you select different versions of the default pawn class, the default HUD class, the default player control class, the default game state class, the default player state class, and a default spectator class. Some of these you won't use, like you probably won't use a spectator class, but these other ones you will probably use as your game gets developed. So you could set the game mode there. If we go back to our level, we can also look at the world settings, and my world settings are open in a separate tab over here. And here we're doing the same thing. These world settings set it for this specific level. So every level can have its own game mode. And when your level loads, it determines which game mode is supposed to be loaded with it. So you could again set your game mode here to any one of these. Right now it's set to none because we're not overriding it. And once you set it, you can then set these. Now we have two ways to set up the game mode, and that is through C++ and Blueprints. Let's begin by setting this up through Blueprints. So I'm going to just go over here. I'm going to save my scene really quick. And we'll just save it here, and we'll call it Custom Game Mode. So we have a scene now. It's always good to have your scene and set up and save so that you're not overriding some other scene that you have for another like sub project. And then I'm going to right click and I'm going to create a new game mode. And the way I'm going to do that is by just saying Blueprint class. And then I can scroll down here and I can see game mode base as the possible base. And then I have to name it, so I will call it Custom Game Mode BP. And I can save it. And then once I've done that, then I can come over here and I can say custom, and I can just type it here, custom game mode BP. And now I've set this custom mode game blueprint to be the game mode that's going to be used in my game here. You'll notice here that now, before these were sort of grayed out, and now I can select different ones. Well, I don't really have any other options. I mean, I have other options from other setups. For example, you remember that there was like a flying pawn that we created in one of the videos. So flying pawn, if I did that, then the pawn that's going to get created is going to be one of those flying ones that we created before. And then I could set up the HUD, I could set up the player class, but most importantly, I would probably want to have my own unique game state. So again, I'm going to come over here to Blueprint class, and then I'm going to scroll down here. This says common classes, because they're the most common ones you'd create, but I'm going to come down here to all classes and say game state base. And we will call this custom game state blueprint. I'm just using BP at the end. That's not something that you have to do. Sometimes you'll see that in Unreal. But the reason I'm doing that is just because I'm going to use sort of similar names when I do this in C++, and I don't want to have to type a bunch of extra things. So it's easy for me to remember. So this will be my custom game state. And then when I come over here, instead of using game state base, I will use custom game state blueprint. So these will be set up now. Now you might wonder why, I want to set these up. And again, the reason is, of course, that we're going to use this as the controller in the main state. And I can access the game state and the game mode from basically any actor. So it's an easy way to have a reference without having to create a specific reference to any of my systems. So for example, let's just add a new how about a cube into our scene? And then once we have the cube, we're going to go ahead and make it a blueprint. I can't set anything there because I'm in the world settings. So we're going to add blueprint. I thought I was missing the little, drop down arrow thing. So we're going to create a new blueprint, and we'll put this into the video game mode folder, and we'll just call this cube blueprint. That's fine. So we're going to create it, and then in my event graph, what you'll see is that I can now access things from the game state. So if I say, for example, game mode, you'll see that I can get a node called get game mode, and this is going to return the current game mode base, right? And so in my event begin play, I can now say cast, and my thing was custom game mode blueprint. So then I can take my game mode here, I can drop it into here, and so now this is going to give me access to anything that is of my game mode blueprint. So when you're using blueprints, you need to do the casting here, because otherwise you won't be able to see anything that you create on those objects. So let's just save this and compile it for a second, and then we're going to go back. Let's drag this over to our set of blueprints. I'm going to close my project settings, and let's go back to the custom game mode blueprint. And on this, we're going to create a function, and the function will be something like get coin count. All right. And then it's not going to take any inputs, but for the outputs, we do need to have a value, and we want this to be, say, just a regular old integer, and it's going to return whatever the coin count is. Now, where I'm going to get the coin count from? Well, you want to separate out your model and your controller, and so I can come back over to my game mode, and to my game window, and I'm going to go to my game state blueprint now. Let's open this up. We'll come to the event graph, because that's the one we're used to looking at, and then we're going to add some variables to it. So here I will add coins. I'm going to change its type to be an integer, and I'm going to make it public. This will be visible to anything that accesses it. And once I have this, I then want to set up a default value. I have to compile it first, because it won't let me set it up without doing that. Oops, I thought I hit compile. There we go. And so let's say there's 500 coins. Now from my game mode blueprint, I can now say cast to game state. To custom game state. Apparently I misspelled custom. It's kind of funny. And I'm going to drag my arrow here. And the object I'm going to use, I'm going to say get game state. I'm going to drag it in. This will give us the cast worked. Okay. And then out of this, we're going to pull this out, and then we're going to say get coins. And then this will return the coins to our blueprint, to our other blueprint. So let's scoot this over a little bit. Just make it look a little nicer. All right, so this is going to get our current game state, and it's going to cast it to the custom game state blueprint. From this custom blueprint, I'm going to get the coins variable out of it, and I'm going to return this as coins. Now, this is the name of it, which I don't like, so I'm just going to call this coins. Okay, then I can compile this and save it. And so now this gives me a function inside of my custom, my custom game mode. So now if I go back to my cube blueprint, if there's some reason I wanted to get these coins because I'm going to set something on it, like on the player or something to that effect, then I can do a similar thing. And here I'm just going to print string. And out of this custom game mode blueprint, I'm going to call the function get coin count. Oops. And I'm going to put this, my execute wire into here actually. And then drag this out. And then this will do a nice little conversion for me. And so I can convert my coins into the string and I can print them on the screen. So, the whole point here is really to give you an idea of how we use our controller. Our controller really is going to provide functions for manipulating the data. And then we sort of leave the data pure by not, messing with it or putting a bunch of complicated logic inside of it. Now you can still do that. So it's not like against the law to do that. But it's just a better design often to have that sort of in a separate function or in a separate class in your controller so that you know where all the game logic is happening and you're not having to hunt it down or you change something and it breaks everything else. So, so now if we just take our project and we compile it and run it, you'll see that I get the 500, which is what I set those coins to using the custom blueprint game mode and the custom blueprint games state. Now, what if we wanted to do all of this inside of C++ instead? And there are some actual good reasons to do this, primarily because the custom game mode in C++ has different things that are called on it that you don't have access to in the blueprints. In the blueprints, it just assumes that begin play is going to be called, but it turns out that there is a function called start play that gets called automatically by the game engine that happens before any blueprint gets its begin play called. So there is some usage to doing that where you might need to have access or initialize things in a certain order. And so you can be guaranteed that your game mode is going to call this function called start play before it ever happens inside of the blueprints. So let's look at how we can set that up. First, we'll go ahead and just say create new C++ class. And then we can just scroll down and look for that's GameState base, which we want, but we want game mode base. And then we need to give it a name. So we will call this custom game mode. I don't need to call it base. And then I'm going to just put this in a folder. So videos, game modes. And then I'll say create class. And this is going to go ahead and add this to my project. And then I'm going to rebuild my project just to make sure that everything works initially from the get-go. So we have that rebuilt now, and if we look over here in C++ classes, in my video section here, you'll see game modes, and you'll see a new game mode here that's based off of C++. If I go over to my project, though, I can set up things with my game mode. Now, if you notice, my game mode is pretty empty. It doesn't really give me a whole lot of things set up with it. So we're gonna have to set up our own constructor and things like that. I think that often people just aren't setting up their own game modes in C++. I don't know why. I mean, it's a fine place to do it. And so we're gonna have to set up our own constructor. So custom game mode, which will look like that. Whenever you have anything with virtual functions, you always need to make a virtual destructor. So a custom, game mode. I always seem to be putting an E after the word custom. It's going to look like that. And we'll use a little bit of C++ 11 here, which is, we can set up the default destructor. And so that's our constructor and destructor. And then we want to make sure that we define it over here. So a, custom game mode. a custom game mode. So that's our constructor. And really, the only thing that you're going to do in your constructor is set up your default classes. So while we're at it, we're going to go ahead and create our default game state, because we want to make sure that that gets set up properly too. So I'll say new C++ class. And here I will look for game state base. And we'll call this custom game state. Create the class. And this will take a second to get set up. Okay, so my compile is complete. And just to point out something really quick, if I come over here to world settings and I change it to custom game mode instead of custom game mode BP, so custom game mode, you're going to see that these are grayed out again. And so what we want to do is be able to set our game state class, but I can't set it here. I have to do that instead in C++. So let's look at the custom game mode CPP. We're going to come back over here. And in the constructor, what we will say is game state class equals a custom game state static class. This static class thing is an unrealism, I guess we might call it. And this has to do with their whole object system and the way that they were doing garbage collection and things like that that were created, a long time ago when they were doing Unreal 3 and probably prior to that. But it's not a C++ specific thing. But this is how you can get the static class to be set up here. So this is set up now, and if I recompile this, what we'll see is that my game state class is going to be set up properly. So I'm going to go ahead and compile that, and then we'll take a look really quick. Well, my build failed, and the reason is because you have to include, of course, the actual header file. So custom game state.h, and then that should build properly. Okay, so now if I come back over to Unreal, what I'll see is that my custom game mode now has custom game state as the game state class. It's important because it's going to get created when the game mode is created, and you want to make sure you have the right state object built. So let's go back and add a few things. So in our game state, we're going to do a similar thing to what we did before with just something randomly called coins. And again, this class is very generic. There's nothing in here. Make sure you make these things public because you'll need these. So a custom game state, and of course the virtual destructor, a custom game state equals default. And then on top of that, what we want to do is have some coins, right? And the way we do this is by making a U property. So U property, we'll make this edit anywhere, blueprint read write, and this will be an int32 coin count. We'll call it coin count. And then in our constructor, since we've defined it, you actually have to define it here. So otherwise you're going to get an error about probably a bad vtable or something to that effect. So a custom game state. And here we will say, well, we'll use the C++ style of initialization. And we'll say coin count 500 there. So this will set it to be 500 coins initially. So let's go back to the game mode. And we want to define a few more functions for our game mode so that we can fire some events to our blueprints from here. So let's set up a few functions first. So the first is, if you remember, we set up a couple of functions that allowed us to modify the state, and so we can do that through here. we'll define a U function, and these will be, the first one will be Blueprint Pure, and we're going to give it a category. We'll just call this coins. And this function is going to look like this. It's going to be virtual, int 32, get coins, and this is going to be a const. And then on this side, in the C++ file, we're going to say int 32, a custom game mode, get coins, const, and this is how we define it. Now, when we define these functions here, we can put a comment that will be the tooltip for the function in Blueprint itself. So return the number of coins in the game. Something silly like that. Now here, what we want to do is actually get the game state, and we want to just return the coin. So that's fairly easy. We're just going to say return get game state. Now this is a function that lives on the game mode base. And so the type that we want to pass into it is custom game state. And then this is going to, it's a template function that's going to give us the right type. And then we're going to call it coin count. Right, then we will save this. We'll compile it to make sure that it works, and then we can add some more stuff to it. So that failed, mainly because I didn't put my right name, because all of these classes begin with an A. So don't forget that little thing. So this will allow us to get coins, and with this we're going to define another function, another U function, and we will call this Blueprint callable. And again, we'll put it in the category equals coins. And this will be a void, so it's not going to return anything. And we're going to call set coins, and it's going to pass in an integer, just like that. And then on the other side, we'll simply do a similar thing. So we'll say a custom game mode, and we'll say set coins, int 32, new coins, and then we can now do a similar thing that we did before, which is get game state, a custom game state, coin count equals new coins. So what's the difference between these two? Well, one is Blueprint Pure, and if you were to look in Blueprints, what you would see is that there won't be an execute wire for those. And that's because we're guaranteeing that we're not going to modify the underlying object. And this is just part of one of the designs of certain kinds of visual languages, where you'd like to know which things can be sort of executed out of order. So for the pure functions, these are easy to call. It doesn't have to worry about any kind of side effects, and it just knows it's going to get something out of that node. If we look at, and I think they're colored green if I recall correctly. If we look at Blueprint callable, these are basically making calls into C++ that might have a side effect. And so set coins is going to do that because we're going to change the state of something. And as you can see here, that's what we're doing here. We're actually changing the state of the underlying game state object. So that's mainly the difference between Blueprint Pure and Blueprint Callable. Not much of a performance difference. These might be slightly faster, and like I said, they can be reordered. These will have to have an execute wire into them, and then you can carry that execute wire out of it. Now, as I said before, custom game mode, your own custom game mode in C++ will have some functions that are called that you don't have access to in Blueprints. So I'm going to show you how we can get sort of access to those. The first of these is start play. Start play is called before any function is called, any begin play is called on the objects in the world. So it just simply is defined like this. It's a virtual function in C++. And so if we override this, we're going to override how start play is called. Let's go ahead and do that. And again, we're going to just use the same name here. Oops. And we'll call it start play. And then at some point in start play, usually what you'll see is that you'll call your parents' function in Unreal. This is not necessarily a design pattern you see everywhere, but you do see it in some places, especially with game engines, because there might be some functionality, some sort of base functionality that's built into the game. So here, this is the case. When start play is called on the game mode base, it then will eventually call begin play on everything. And so depending on when you call this, begin play is going to be fired off on all your objects. So if we want to do anything in start play before all of the begin plays are called, we had better wait to call our parents' version of play. So we're going to put that at the end of our function. Now we'd like to make an event just like begin play in our game mode called start play. This way, if we turn this game mode into a blueprint, we can then access that event. And the way we do that is by saying u function, and we are going to call this a blueprint native event. Again, we're going to put it in the category coins. And we're going to set its display name to be equal to start play. And then we're just going to give it a function type, start play event. So you'll notice that this one isn't virtual, and that's because it's not really allowed to be virtual. What's going to happen is that because we've made it a native event, we can provide a default implementation for this event if you don't define one in blueprints. Now you don't have to do this, and it's a little bit more expensive to do this, but start play isn't called frequently, so it seems fine to me to have the extra cost. But because blueprints is going to be calling back into your C++ class for this native event, if it doesn't have one, it can't be virtual because apparently blueprints doesn't know how to handle virtual functions properly, which is fine. So just don't make it virtual, and know that you can't really then inherit from this and expect this to work. It's not going to work like you expect. So let's go back to here, and we are going to call this start play event. And here is the interesting part about defining the start play event, and it is that we have to now define this as with a slightly different name, and it's going to be underscore oops, I already did the underscore implementation. Right, so what are we going to do for our default implementation? Well, let's just log something onto the screen. So we'll say gengine add on screen debug message. And we'll just make this red. And then we have to pass in text to it. And this text is going to contain something like start play event default implementation. All right, so that will now, this implementation version will be called if you don't define your own. And so you could also, just define this as a different kind of blueprint event where it's not going to do this, but we're doing it here just for funsies. All right, so now that that is created, we can then, from here, call start play event. And when you call this, it's going to call the implementation of that event, and it will, then do the on-screen debug version. And just to be clear, we're going to add one more, nice little logging here. And I'm going to do a similar thing to what I did before. And here we're just going to say start play called. just so that we see what's going on. Now the point of all this, oops, I noticed that I didn't actually call this start play, which is what it's supposed to be called. The point of all this is to allow you to do, you know, some kind of initialization here. Initialize stuff here inside the start play function, and then to do any other kind of setups or function calls from your game. Now, one thing to point out is that, you know, everything that's in your world is made from an actor. And because of that, if you need to get your game state anywhere, it's actually pretty easy. You really just have to say get world. So every actor has access to the world that it belongs in. And then you could say get auth game mode. And then once you do this, this is going to give you the game mode base, you know, class. And then you can cast it to your game mode if you want to access it. Well, I mean, we're inside our game mode, so there's no point in doing that. But let's say I wanted to get the game state at this point, then I could say get game state, a custom game state, and then I can do things with that game state. So, you know, just to point out, the reason that we use game mode is that it now gives us an easy way to get the game mode from whatever actor we're in and that's currently active in our world. If for some reason your actor's not in the world, then get world is going to actually return null, and then you're going to throw an exception because you're going to try to dereference the null pointer, which of course crashes your game. So you should be a little bit careful to make sure that your object has been created, but game mode can't actually exist without being inside a game world. I mean, I guess you could probably remove it because it is C++ and Unreal. So, but for the most part, this should be fine, and anything else is really definitely a bug in something that you've done. So this should give you an idea of how to get, you know, how to set things up and how to start setting things here. So let's go ahead and, let's go ahead and set something here. So coin count equals 150. So in essence, I've initialized it by changing whatever its default game state was to now just be 150. So then when I compile this, I should be able to see that all of these changes exist inside of Unreal, and now I can turn these into blueprints themselves. And then that will be really nice because I can extend these and get the events that I can't get off of the regular blueprint version. So let's go ahead and compile it and do that. So when it finished compiling, it gave me an error because I used the dot operator instead of the arrow operator, because this is actually returning a pointer to me, not a reference. And so you want to make sure that you have saved this and that you're going to use the arrow instead in order for this to work. Very good. So it's compiled, and if we hit play, we should see some messages that pop up. So start play called, start play event, default implementation called. So you can see that, you know, there wasn't something in Blueprint, so it called the default implementation of that event. But what's even better is that we can now take this custom game mode, we can right click on it, and we can say create blueprint class from it. And so let's go ahead and put this into game modes, and we'll call this my custom game mode blueprint. I have a lot of classes that are named very similarly, and I'm going to go ahead and close my other blueprints here since I don't need those. And now we'll see that from this event graph, there's going to be a new event I can create. Oops, I need to stop my game first. If I right click here and I type event start play, you'll see that I have a new event for start play. And this start play is going to be called whenever the start play in the game mode is called, which is going to happen before any possible begin event happens. So let's say print string start play called, and then from begin play, print string begin play called. All right, we will compile these, and then I need to change my game mode to be my custom GameMode Blueprint. And then we can run this, and you'll see that, you know, my other, these didn't last very long, but my start play and my begin play were called. If you rewind and pause the video, you can see them pop up really quick. But also from here, you know, I have access to those functions that I created. So, you know, if I wanted to set the coins, say in begin play, let me stop this from simulating. I can say set coins, and you'll see that it is my game mode, and I can set it to whatever I want. Well, I don't need to set it in there, but I can set it to here. So 250, for example. And then this will just set the coins value in the game state. So hopefully this gives you an idea of, you know, this work between the C++ game classes, game mode classes, the game state, and the blueprint versions. And it is the case that, you know, you might create some of these in C++ because you need access to being able to do these things early. And then you might extend them because, you know, customizing some of these events is a lot easier to do in blueprints, especially when there's not a lot of calculations that have to happen or a lot of time-consuming things that might slow down the starting of your game. So, you know, it's a balance between these two things, and I encourage you to think about, you know, what you might need. But really, the important lesson here is the purpose of the game mode, which is to act as the controller or the logic in your game, where you create functions that can modify the model, which is your game state, but also which have functions that define, you know, how your game plays and how things run. And again, you know, you're going to define, because this is an object-oriented language, you're going to define custom functions inside the players directly, inside the controllers directly. So this doesn't have to all exist inside one game mode. But the game mode will have rules, or should have rules, about how the game actually plays out to determine sort of the end of a level or the end of a game for a win state, or however you want to think about it. All right, hopefully that helps. And please send me any questions if you have any.